Welcome again to a new topic. We are now on standard form. Alright, so when we're talking about standard form, we are talking about writing numbers in the form a by 10 to the power of n. And in this case, a will be a number that is between 1 and 10. So that will be our a, and n will be an integer, simply be an integer, positive or negative. So this form that you're seeing here is what we call the standard form. Right, so you can have numbers like 2.23 times 10 to the power 3. This is an example of a number that is in standard form. And another number in standard form, 4.6 times 10 to the power of negative 2 is another example of a number that is in standard form. You can have a number like 7 times 10 to the power of 20. It's another number that is in standard form. So you can see that these three numbers in standard form are conforming to our standard form rule here, that a should be a number that is between 1 and 10. You can see here that we've got 2.23, which is between 1 and 10. We've got 4.6, we've got 7. These are our values of a, and these are numbers between 1 and 10. A number that is between 1 and 10 is a number that has got one digit before the decimal point. So as you can see here, we are saying that the value of a has one digit to the left of the decimal point. Our a is this value, that is this value here. Alright, and you can also see that the power, that is the power of 10, is an integer. An integer is a whole number, positive or negative. So this is what we call the standard form. So why should we express numbers in standard form? Alright, I want you to consider this. Now look at this fact here. The distance from the earth to the moon is approximately 384,300 kilometers. I want you also to look at this fact. The world human population is approximately 7 billion people. Right, I want you to also look at this another fact. The size of a cell organelle that they call the mitochondria is approximately 0.000001 meters. One more fact, so this is 1 micrometer. One more fact is the diameter of a genetic molecule called DNA is approximately 0.000000002 meters, and they call this 2 nanometers. Now if you look at all these figures, which we can find in science and statistics, you can see that we are dealing with very large figures and very small figures. Now as numbers become very large and as numbers become very small, then it may be a bit difficult for us to be dealing with those numbers or to understand how big or how small they are. So standard form is a way that we can write such figures in a standard way so that we can easily interpret the magnitude of those values. So for the distance of the earth from earth to moon, simply in standard form would be having something like 3.84 times 10 to the power of 5 kilometers. For the world human population, we'll be having something like 7 by 10 to the power of 9 people. For the size of the mitochondria, we'll be saying that it is approximately 1 by 10 to the power of negative 6 meters in standard form. And for the diameter of the DNA molecule, that will be 2 times 10 to the power of negative 9 meters. So you can see here that we are now expressing all these very large and very small figures in a standard way, and it's easier for us to interpret the data. From here I can see that the distance from the earth from the moon is 3.84 times 10 to the power 5, and I can see that it's a smaller value to this one because I'm looking at the values of the powers. So we shall be looking deeper into that. In this topic we shall be talking more on how to convert from ordinary form to standard form, and also from standard form to ordinary form.